Okay, so here we are at test hints for chapter 4. We're doing the 1 through 12 in my third period class today, and the other sections are going to be posted when we go over them with the other classes, so make sure you watch all the parts. Are we ready?
No.
Can you guys over there see me in the back of the... Okay, so I have it set up right. Ooh, okay. Identify the man who was the first to suggest the idea of the atoms. You guys look out, because you get the beginning of the chapter where it's easier. Democritus. Democritus, the Greek philosopher, yes. Define or describe an atom. So what is an atom?
Building blocks for matter.
Building blocks for matter. How else could we say it? Smallest particle of matter that does what? Retains the
shape, identity.
And?
Shape.
Shape, identity, color, all the properties. Shape not so much, but it retains all of the properties of that substance. Smallest particle of matter that retains all the properties of the substance. Okay, now we have Dalton, John Dalton. Describe his theory and the changes and exceptions to it. So Dalton's theory had 5 parts. First, the idea that everything was made of atoms. Then what? What else did he say about those atoms? We kind of touched on it just now with the other one. Cricket sound. Atoms of the same element are chemically alike. They have all their properties alike. So if we have a whole bunch of carbon atoms, they're all going to be the same. Their color, their density, how they combust, all that kind of stuff. And then if we have a different kind of atom, it is going to be chemically different, but all of those atoms are going to have the same properties. There were 2 parts that he was not quite right on back in the 1800s that we know better now that we've done quantum physics. What is one of those 2 things? More crickets.
They're atoms of different elements or chemically different?
We had that. What did he not know existed? Neutrons. Protons. Electrons. So back in the early 1800s when he was coming up with this theory, his explanation, he did not know that there were particles smaller than atoms. That's one thing that we know now. And one of those particles has an effect on the other part of Dalton's theory that wasn't quite right. In fact, we've been looking at it with the Bean Lab a little bit, and we talked about it yesterday in notes. What do each of those particles do? They give it a charge. What?
Like the amount of neutrons in isn't there carbon 14 and carbon 12?
Yes, there's carbon 14 and carbon 12. There's also carbon 13, 15, 16, 17, and 18. Those are different isotopes. And how are isotopes different from each other?
Neutrons.
No, different, only one thing, neutrons. Different numbers of neutrons. That adds different mass. Now, Dalton's theory originally said all the atoms are chemically alike. They have all their properties alike. So he'd think all carbon atoms would have the same mass. But now we know about the subatomic particles. We know there are neutrons, and we know that that mass can vary. So the differences in mass and the fact that there are things smaller than just atoms were the parts that we've adjusted in the theory. Identify the subatomic particles and the similarities and differences between them. So what is something that is true about all subatomic particles?
They each have a charge.
They have a mass.
They have some sort of mass, but it is incredibly tiny, right? Yeah. And how does the mass of electrons compare to protons and neutrons?
Much smaller.
Much smaller. About how many times? Because I'm sure that'll be somewhere else. 1/18 something. 1/1837th, which is approximately 1/2000th. Right? So about 2,000 times later. You may see that either way. What is different about each of the subatomic particles?
Charge.
Their charge. So we've got protons that are what?
Negatively charged, positively charged.
What? Protons are not negatively charged.
I said positively charged.
Protons are positively charged.
I was going for
And electrons are
negatively charged.
negatively charged, and neutrons are
Negatively charged.
no charge.
Trap.
Okay? No charge. So, if I said something like, the electron is negatively charged and it's the heaviest particle, would that be true about atoms? Think. Let me say it again. Electrons are negatively charged and they're the heaviest particle. Why is that false? Because they're the smallest or lightest particle.
The nucleus.
Someone is in the hall being an idiot.
Who are they?
It's Chem.
No. Okay. Compare the masses of each of the three subatomic particles. That will be something similar to this. Okay, we kind of talked about that one already. That was number 5. Number 6, describe the atom in greater detail than our question number 2.
Made up of 3.
So, again, we're touching on all these things with our answers to the questions we've just gone over. What can you, describe for me an atom of lithium. Let's look at lithium. We'll just, no, we did lithium on the building game. Let's do oxygen.
Done.
What can we say about an atom of oxygen?
8 protons.
And where does that go in a nuclear symbol?
Top.
Top right.
Oh, no.
Protons
Top
are
left.
No, what?
Protons are on the top.
Bottom left. 8 is the atomic number.
Yeah, but 8's also.
That is the number of protons. Okay?
Alright, is the atomic
And
number.
what else? Is what?
The atomic number and the protons are the same number, right?
Yes, the atomic number is the number of protons. It tells us the same thing. And what other particle is the same? Electrons. The number of electrons, because the atom needs to be electrically neutral. And then what number in a nuclear symbol goes up here? The atomic mass. And we need to look at, we'll pick one isotope. Let's pick the most common isotope of oxygen. So we glance up at our periodic table. Yeah, oxygen 16. Okay? So, in the nucleus of this atom, there are a bunch of particles. And how many protons? 8 protons. Yeah, we just said that. It's not a trick question. How many neutrons? Why are there 8 neutrons? Right, 16 minus 8 would give us the number of neutrons. It just happens that in this example, all the numbers are 8. And then if we have 8 protons, we also have 8 electrons. Okay? How often do the electrons visit the nucleus of an atom?
Never.
Never. Okay.